Welcome, happy learners, to another Desmos demo.
Function sine of x, f of x equals sine of x. That plots out. Let's change our view here. Let's adjust the y-axis from negative 1.5 up to positive 1.5. Move the grid. And let's make the x-axis go from negative 20 to positive 20. Okay, so we have the graph of sine in our window. Now let's make the nth Maclaurin polynomial. So we'll name that p sub n. Make that into a function. We'll use summation notation. We want to start our index at 0 to include constants. And then I've labeled it p sub capital N, so I'll use capital N as the stopping point. Make a definition for capital N. Pick any value. We'll have this begin at 0. Step size of 1 to make sure that n, capital N, is integer valued. Good. See the video on sine is odd to verify that the sine wave, f of x equals sine of x, is an odd function. That's a nice reminder that in writing out the Maclaurin polynomial, that we'll only use odd terms. So first off, it's alternating, so negative 1 to the n. And then the oddness comes in the form of x raised to, well, we only want odd powers. So how do we get that? 2n, that would be even. So if we add in 1, then we're assured that we're working with odd powers. Let's put a little 1 plus to trick Desmos into allowing us a sum in the exponent. So 1 plus 2n plus 1 is the same thing as 2n plus 1. And we want that denominator, 2n plus 1, to be quantity factorial. Excellent. So then for various values of n, here we have n equals 6. This is the sixth Maclaurin polynomial that approximates sine of x. Let me highlight n. And then you see for inputs near the origin that the red polynomial curve does a fairly good job of approximating the sine wave in green. And then we can hit play on the n. Let's make an upper bound on capital N. Let's say 50. And then let's hit play. And that's going pretty fast. We can slow the animation down. Something like that. We can hide these expression lists. Zoom out a little bit. And watch, here the n values are coming down till we have a constant. And then the n values are now going back up. And as the n values go up,
Like and subscribe if you find this useful.
Do a better and better job of approximating the sine wave. And the question is, well, if we took all powers n, would we recover the green curve? Shorter answer is yes. Big question is, why? Enjoy. Let's save this and
Copy the link.
into the description.
Like and subscribe if you find this useful.